All right. So before you guys ask any questions, which you guys will have time in a sec to do that, a couple things I just want to review real quick. So when we are doing limits to infinity, and these are all limits to infinity or negative infinity, if you don't have a fraction, if it's just a polynomial, all right. So like for b, the only thing you have to worry about is the leading term. Now, you have to be careful that it's written in the correct order. This is not in the correct order, right? This should be negative x cubed plus 4 is the correct order, right? So negative x cubed is my leading term. It's not 4. So I don't care about 4. I just care about negative x cubed. If I plug in infinity for this, right? Infinity cubed is positive, but there's a negative out front, which means it would be negative infinity as my answer. All right. For D, you would just have to plug in to here. None of this matters, right? You only plug into the leading term. Infinity, a positive number to the eighth, is going to be still positive. So the answer is just positive infinity. Okay. Now, the other ones, which most of them were fractions, remember, there's the three cases. You have to look at the degree on the top and the bottom. But once again, you have to be careful about that. They might not be in the right order. All right, just look for the highest exponent. If the degree is larger on the bottom, that's the one we like the best because it's automatically 0. All right, the answer, the limit will be 0 because the horizontal asymptote is 0. If the degrees are the same, then you take the coefficients in front of each of those and simplify them, and that's your answer. And then if the degree is larger on the top, then it's either positive infinity or negative infinity. You take the two leading terms, simplify, plug in, and go from there. So if you look at A, right, this has a degree of 3. This has a degree of 3. That's the highest. Notice the bottom is not in the correct order, so you got to be careful. So they both have the same degree. So you take the coefficient. The coefficient on top is 1. The coefficient on the bottom is 3. So the answer is just 1/3. Simple as that. All right. Look at something like C. There is no x on the top, which means the degree is 0. The degree is 3 in the bottom. The degree is larger on the bottom. Love that. It's 0. All right. If I look at one like F is larger on top. It's 4 on top and it's 1 on the bottom. So what we're going to do is take the two leading terms. So in this case, the answer is either going to be positive or negative infinity. You got a 50-50 shot because this is a slant asymptote. So you get 2x to the fourth over 5x. The x is going to cancel here. This is becoming 3. So it's 2x cubed over 5. And now substitute in your negative infinity. A negative number cubed is still a negative number. Times a positive is still a negative. Divided by positive is still a negative. So it's negative infinity. All right. All right. So those are the fractions. Other one I want to go over was J and O. These trig ones. We didn't talk about any trig yesterday, but these are actually very easy. If you think about what the graph of sine looks like, sine starts here and just keeps following this pattern, right? Like, and this goes on forever. So as x goes to infinity, right? As I go to the right, is it ever approaching a same y value? No, it goes up to the top, then it goes to the bottom, it goes to the top, bottom, top, bottom. So if there's not a limit, we say the limit does not exist, D and A. So anytime you have a sine limit going to infinity or negative infinity, it will always be D and E. And the same thing is true for cosine, because cosine is basically the same thing, except you just start at the top. All right. But you're still waving in all the way there. So if you see sine or cosine, it's actually really easy. It's just D and A. All right. Were there any other? Let's do this real quick too. L. Just because the square root's up top, don't worry about it. Square root of 5x squared. Don't worry that 5 is not a perfect square. Square root of 5 is the square root of 5. The square root of x squared is x over 2x. Now remember, since I'm going to negative infinity, I have to use a negative x. If I was doing a positive infinity, then I use a positive x. They cancel, and you get negative root 5 over 2. All right, negative root 5 over 2. All right, does anybody have any other questions on any of those? Are just ones I wanted to point out. Was there any other specific questions on any of them from A to O, any of the limit ones before we get to the asymptotes? All right. So the nice thing about all these asymptotes, all right, remember, to do all the vertical asymptotes, you just set the bottom equal to 0, right? So all of these. So here, set the bottom equals 0. That's -4. So the vertical asymptote is x equals -4, right? This one is x equals plus or minus 2. You just set them equal to 0. This one is x equals 5, and so on and so forth. Now, for the horizontal and the slant, you're not going to have both of them. There's only going to be one. The only time you have a slant is if the degree is larger on the top. In this case, the degree is larger on the bottom, so it means it's automatically 0. So it's y equals 0. Nothing for the slant, so just put a little slash through it. Right? This one, the degree up top is 1. The degree on the bottom is 2. Once again, it's larger on the bottom. 0 is your horizontal asymptote. There is no slant. Right here, the degree is 1, the degree is 1. They're the same, which means you take the coefficients. 1 over 1 is 1. So the horizontal asymptote is y equals 1. There is no slant. All right. So you just have to, do that. Well, this is a little off kilter here, but just because there's something in the bottom does not mean that there has to be something that makes this equal to 0. If I set this equal to 0, I get x squared equals -4. When I take the square root, that's an imaginary. So there is no real number that makes that 0. So there is no vertical asymptote. The horizontal asymptote in this case, 2, 2, because the degrees are 2, which means it's y equals 2. And there is no slant. All right. So any questions on those? All right, so on this same worksheet, we are going to work on, let's start with an easy one first. All right, we're going to do this example right here. All right, so for each of the functions listed below, find the derivatives and the critical values. Next, construct number lines to show where the original curves are increasing, decreasing, concave up, concave down, then list the relative max, min, points of inflection. Finally, put all the information on one big number line and sketch. Okay, so all of this right here, this is all one problem that we are going to do, this whole thing. All right, a lot of parts, but it's basically just a bunch of little problems all within one. All right, and it's basically divided up into I want to say 4 sections. The first section that we are going to worry about is this one right here. 6 things they have to answer. All of these have to do with the original function. We're not using anything with the derivative yet. All right, it's all based off of the original. So we're going to look for the vertical asymptote, horizontal asymptote, slant asymptote, x-intercept, we're across the x-axis, y-intercept, we're across the y-axis, and symmetry, meaning even, odd, or neither. Okay. So to do the asymptotes, we just talked about that. Now, this is a beautiful thing. This is nice. 3 easy points on an assessment when you have a polynomial. There are no asymptotes in a polynomial. There's no fraction here. So put a slash, put a slash, put a slash. There you go. 3 points. All right. That's all you have to do. All right. To find an x-intercept. All right. To find an x-intercept, what you're going to do, x-intercepts are where it crosses the x-axis. The y value is 0. So what you're going to do, and I'm going to write this, set the top equal to 0. And you're like, why do you say the top? Because there is no fraction. Well, because when there is a fraction, you want to set the top equal to 0, and that's how you find an x-intercept. Technically, there is a top. It's over 1. So we're going to set x cubed minus 3x squared equal to 0. That's how you find x-intercepts. All right. You set it the top equal to 0. If there is no fraction, you're just setting the whole thing equal to 0. So if I were to set this equal to 0, I would take out an x squared, and I get x minus 3, right, equals 0. So the 2 values that make that equal to 0 are 0 and 3. That's where it hits the x-axis. So I have two x-intercepts, right? 0, 0, and 3, 0. All right, so to find the x-intercept, you set the top equal to 0. Okay. To find the y-intercept, all right, y-intercepts, the x value is 0. So you're going to plug in 0 for x and simplify. So you're going to plug in 0 for x wherever you get that. Now, remember, all of this is into the original, right? All 6 of these things have to do with the original function. Okay. So when I plug 0 in there, 0 minus 0 is 0. So the y-intercept is 0, 0, right? If the x-intercept is ever 0, 0, guess what? The y-intercept is also going to be 0, 0. Right? So that's for every type of function. To find the x-intercept, you're going to set the top equal to 0, which means if there's a fraction, set the top. If there's not a fraction, you set the whole thing equal to 0 and solve. You can have more than one x-intercept. You will only have one y-intercept, and that's you plug 0 in for x, and then you simplify. All right, symmetry is the one that gives normally the most issues just because we don't use it as much. I don't want you to, stress about this, but if you remember, even you guys did this in pre-cal, even symmetry and odd symmetry, it's how the graph, even symmetry means it's reflective over the y-axis, which means you flipped it over the y, it looks exactly the same. Odd symmetry means it's reflective, it's symmetric about the origin, which means if you rotate it 180 degrees, it's the same graph. Algebraically, which we're going to have to do here, how to figure it out, we are plugging in negative x. And if f of negative x equals negative, if f of negative x equals f of x, the function is even. So you plug in negative x for all the x's. If you get exactly what you started with, then it's an even symmetry. If you plug in f of negative x and you get the exact opposite, negative, if you get negative f of x, that's odd. If none of those things happen, it's neither, which happens a lot. All right. If you were going to guess neither. All right. So for this problem, I'm going to change the color up here. X cubed. So instead of x, I'm going to put negative x in there. Cubed minus 3 times negative x squared. Okay, now just to show, if this to be even, I have to get the exact same thing, x cubed minus 3x squared. For it to be odd, I would have to get the opposite. So I need to get negative x cubed plus 3x squared. So if I get the original, if I get this, it's going to be even. If I get that, it's going to be odd. If I don't get either of those things, then it's neither for symmetry. So negative x cubed, that's going to stay negative. This negative x squared goes positive, but times a negative, it's negative. So I get negative x cubed minus 3x squared. That's not the original, and it's not the opposite, because this is negative positive, this is negative negative. So the symmetry is neither. All right. So when you have a polynomial, and what will probably end up happening on your, whenever we get assessed, it'd be very similar to your last quiz where you have a polynomial and then a one with a fraction. The polynomial one will not have any asymptotes. All right, to find x-intercept, you set equals 0. Find y-intercept, you plug 0 for x. Symmetry, you plug in negative x, and then look at it. All of this has to do using the original function. All right, any questions on how I found any of those 6? Okay. All right, so now, once we get that past that part, all right, now it's exactly what we did on our last quiz. So now we go to the second and third part, which is what we've done before, which, let's see, right? First derivative, I'm going to just break this up. We have our first derivative. We have a number line, so that's where we put our critical values. We figure out where it's increasing, decreasing, our relative max, relative min. We do our second derivative, critical values, wherever it's positive, it's concave up, wherever it's negative, it's concave down, points of inflection. Exactly what we did on the last quiz. So just like on the last quiz, if it's a polynomial, I'm not going to give you the derivative. You guys can easily figure that derivative. So I'm going to give you a few minutes. Go ahead, see if you can find the derivative, fill all this in, good review of what we did last week. Give you a couple minutes to try that out. Okay. If you didn't finish that part, no big deal. So take the derivative of x cubed, 3x squared. Derivative of negative 3x squared is negative 6x. So to find the values, the critical values that go on the number line, he said equal to 0. So I take a 3x out, leaves me with an x minus 2. So I get a 0, and I get 2. All right, now remember, all of this we are plugging into the derivative, all right, not the original. We only use the original for y's in this part. So any negative number I put in there, 3 times a negative is a negative minus a negative is a negative, but a negative times a negative is a positive. If I put in 1, that'd be a positive on the outside. 1 minus 2 is a negative, so I have a positive times a negative, which is a negative. Anything bigger than 3, positive times a positive, positive. Remember, wherever the first derivative is positive, that's where the original is increasing. So I write those intervals out, negative infinity to 0, union 0 to infinity. It is decreasing from 0 to 2. Now, to find my max or mins, you look to see where it changes on the number line. So since it goes from plus to minus, that means it's increasing and then decreasing at 0. That is a max. So I put 0 there. The min is at 2 because it's going from decreasing to increasing. That is a min. To get the y coordinates, that's where you plug back into the original. Plug in 0, I get in 0. Plug in 2. What is that? That's 8. 2 squared is 4. So 8, 4, 12. So 8 minus 12, -4, I believe. Hopefully I did that right. Okay. So you get 2, -4. All right. Any questions on the first derivative? Like I said, this should be a review, but just in case you forgot to do something. So now, second derivative is 6x minus 6. Take the derivative of the first derivative. Set that equal to 0, you get 1. Only one critical value here. So if I plug in anything to the left, so plug in 0, remember plugging into the second derivative. If I plug into the second derivative here, if I plug in 0, I get a negative. Anything bigger than 1, I'm going to get a positive. So wherever the second derivative is positive is where it's concave up. So it's 1 to infinity. It's concave down from -infinity to 1. Wherever it changes concavity, it doesn't matter if it's minus to plus or plus to minus, that's a point of inflection. So at 1, it changes. I plug back into the original, which is 1 minus 3, which is -2. All right, so we get those points. Any questions on that? So like I said, these two sections should be reviewed. All right, now, what we're going to do is we are going to use all of this information. We're going to use the information from these first 6 things and all these 2 middle sections to able to graph. And what we're going to do is we're going to combine the 2 number lines into one big number line. All right. And what we're first going to do is we're going to put any critical values that we found in either number line for the first derivative and second derivative. If they were there once or twice, it doesn't matter. As long as they're included in one of the number lines, you need to put those numbers in there. So we have 0, 2, and 1. So I'm going to put 0, 1, 2. All right. If there was more, you put as many as there were on those number lines. That's how it should be on here. Then what we're going to do on the top part of the number line, I'm going to fill in increasing or decreasing. So it was increasing anywhere less than 0 and greater than 2. So increasing, increasing. It was decreasing anywhere between 0 and 2. So between 0 and 1 it has to be decreasing. Notice between every set of numbers I am writing, even though it's from 0 to 2, I'm just going to write one big decreasing, but decreasing there and decreasing there. All right. On the bottom, I'm going to put concavity. So it was concave up anywhere bigger than 1. So here's 1. So it was concave up here, and anywhere less than 1, it was concave down. All right. So what I've basically just done is I now know what the curves look like on every interval. Okay. Now, so I know everything less than 0, the function is increasing and concave down, decreasing and down, decreasing up, increasing up. So what you have to know is how to actually draw those curves. All right. And this is a great example because it gives us there's 4 possibilities that can happen. All right. So to be increasing and down, a curve looks like this. If something is increasing from left to right, it's going up. To be concave down, it looks like that. So that is an increasing, something that's increasing and concave down. Compare it to increasing and concave up, looks like that. Decreasing and concave down, looks like that. Decreasing and concave up, looks like that. All right, those are your 4 possibilities. If you notice, you put these 2 together, they form the parabola going down, right? One side is increasing, the other side is decreasing, but they're both concave down. These 2 over here, if you put those together, they're the 2 parts of a parabola facing up. The left side is decreasing and concave up. The right side is increasing and concave up. All right, this part seems to give students the most trouble is sometimes just figuring out what the curves should look like. Obviously, the more practice you do with it, the better you will get at it. All right. So does anybody have any questions why this is increasing and down, decreasing and up, or increasing and up? All right. So now we're able to graph. All right. So the steps that we are going to follow. All right. We are going to plot. This is what you need to plot. You need to plot any asymptotes or your x-intercept, your y-intercept, any relative max or mins, and any points of inflection. So any points that we have found previously, we are going to put on the graph first. That's the first thing we're going to do, along with any asymptotes. Now, there are no asymptotes in this problem, so we don't have to worry about that. X-intercept was 0, 0, and 3, 0, and our y-intercept is 0, 0, so we don't have to do that twice. So 0, 0, we're going to plot that, and I'm going to plot 3, 0. All right, I'll just label that as a 3. So those are my two x-intercepts. The y-intercept was also 0, 0, so I don't need to do it again. Relative max and mins. Oh, well, here's our max is at 0, 0, so I don't need to graph an error point. Relative min, 2, negative 4. So just label 2, and then sometimes these numbers, I will warn you, could get like, it could be like 2, negative 100. You're not going to put like slash marks. You just label whatever it is. So in this case, it's negative 4, and I'll put a point right there. And then my point of inflection is right here. That's 1, negative 2. So put a 1, and a negative 2 is roughly there. It does not have to be drawn to scale. Like I said, sometimes these numbers are going to be on the negative or positive side. On the y-axis are going to be large. Like when you plug it in, you might have a really big number. So just roughly, as long as it's, you're obviously not going to put negative 4 here and negative 2 here. All right, so now I have these 4 points. All right, so now I'm going to basically play dot to dot. All right, connect the dots. So we're going to draw our curves. All right, so meaning I am now going to, anything less than 0 is increasing and down. So I have to draw something that's increasing and down. Well, I already know what it looks like. It looks like this. So I'm just going to draw and then put an arrow because it's going on forever, right? So if I look at this curve, it is increasing and concave down. It does not need to be a beautiful piece of work. Art, make sure it's curved, and then I can easily tell it's concave down. Obviously, from left to right, it's increasing. Right? So you see how this curve here matches up from there. Now between 0 and 1, well, guess what? I'm playing from this point to that point. That's 0 to 1. I'm going to do decreasing and down. All right? And it's harder on this mouse to do, but you see, boom, there. And now from 1 to 2, it's decreasing and up. There. And then it is the rest of the way, it's increasing and up. But you have to make sure you go through the x-intercept. And I just missed it. Nice job. Didn't go through, but I would not obviously take off in that case. What you do is you just make your circle bigger. There you go, went through. All right. So you can tell, all right, now we'll go back. So there's our graph. And like I said, easier to do if I was doing it with a pen or pencil and not on a mouse on this computer. But if you look, right, you can see it's doing the proper things. But let's look at the points that we had. 0, 0 is supposed to be a relative max. Well, guess what it is? Look, see how's the relative max there? 2, negative 4 is supposed to be relative min. It is a min. All right. My point of inflection is right here. You can see that it goes from concave down to concave up. All right. So this is our rough sketch of our graph. All right. So we basically just taking the only new thing, it's not even new, is finding the x-intercepts, y-intercepts, and all that stuff. But we're just taking all the information to be able to graph a function. All right. Now, all of that is all one problem, like in theory, but obviously there's so many parts like to that. So, and obviously if you made a mistake on one, it's going to affect your graph. But like I've said all year, you're not going to take you off twice. If you're interpreting your data correctly, you would still get credit. All right, questions? Okay. All right. So what I'm going to do is I'm going to put on the classroom here in a second. Uh, it's a whole bunch of problems, but I'm only going to have you do one, and it's going to be a polynomial just like this. All right. You're going to go through the polynomial. It's going to ask you to find asymptotes, x-intercept, symmetry, first derivative, second derivative, all the stuff. You're going to put it all on the number line and you're going to graph it. All right. And I want you guys to do that problem. To do that problem for tomorrow, and then we'll go over it, and then we'll do an example where you have a fraction. All right. And obviously with fractions, we have asymptotes to take into the mix. So those are a little bit different. And if you just notice that this example here, notice I gave you the first and second derivative, just like I did on the last quiz. And that's what's going to end up happening again. All right. So a few more things that we have to worry about when you have fractions. But we'll do an example of those tomorrow. But like I said, I'm going to put something on here in a second as soon as I say goodbye to you guys on Classroom. And if you guys could try that one problem, that would be great. All right. Questions?